In this video, we'll be looking at section 6.4, which covers solving trig equations. We're going to start by looking at known values. So this is going to involve our unit circle. Sorry, needed to get my unit circle. We're going to solve the sine of t is equal to 1/2 for t being between 0 and 2 pi. So what we're doing is we are finding all of the angles that have a sine of 1/2. On my unit circle, sine is given by the y value. So I need to find all the angles that have a y value of 1/2. And it's between 0 and 2 pi, so we're thinking in terms of radians. So a y value of 1/2 happens here at pi over 6. So t can equal pi over 6. But it also happens in quadrant 2, which is 5 pi over 6. There can't be any more answers than that because in the restriction of 0 to 2 pi, there are 4 quadrants. In 2 of those quadrants, 1 and 2, sine is positive, and the other 2 quadrants, sine is negative. So we found our answer in the first quadrant and our answer in the second quadrant. Next up, we're going to solve the sine of theta equals square root of 3 over 2 for all possible values of theta. You'll notice this one isn't restricted. That's going to make our answers look a little weird in the end, but I'm going to walk you through it. So let's start by finding the places on my unit circle where the square root of 3 over 2 is the sine value. So that looks like it happens up here, which is at pi over 3, which is 60 degrees. I'm going to write it out both ways. And we also want the sine to be square root of 3 over 2. That happens over here at 2 pi over 3, which is 120 degrees. These are the two answers between 0 and 2 pi, or 0 and 360 degrees, that give us the right answer. The problem is it wants all possible values of theta. So the problem with these being our only answers is that we can have angles greater than 360 degrees. If we go all the way around the circle, that's 360 degrees. But if I went 360 plus another 60, that's going to put me back here in the end. That's going to have the same sine value as before. Or what if I went my 60 degrees, but then went backwards 2 pi? That's going to have me end up here. So the way this is going to work, let's think of it in degrees first, because that's how I was just referring to it. In degrees, theta can be equal to 60 degrees plus 360 degrees times k, where k is an integer. What that's saying is go to your 60 degrees, then you can go around the circle 360 degrees however many times you want in either direction. But we also have another answer because of the 120 degrees. So theta could also be equal to 120 degrees plus 360 degrees k, again where k is any integer. So you can go to 120 degrees and then go either way around the circle as many times as you want. If we wanted to think of this in radians, it's the same idea. Theta could be pi over 3. But instead of thinking about it as 360 degrees, it's 2 pi radians to go all the way around. So we would say 2 pi k, again where k is any integer. Or theta could be 2 pi over 3 plus 2k. to pi k. Pi's are important, again, where k is any integer. So once you find the angles between 0 and 360 or 0 and 2 pi that work, add 360 degrees k or 2 pi k, depending on if you're in degrees or radians, and that'll just get all of your possible solutions ever. We're going to switch up into values that are not known to us. These ones can get a little bit tricky because we are so used to our calculators telling us the answer every single time, but unfortunately, we are going to have to be smarter than our calculator for some of these. So first up, we want to find all solutions. So we're going to do the 2 pi k thing or the 360 degree k thing. The sine of theta equals 0.65. It's not telling us whether to use degrees or radians. In the homework, it'll actually tell you. Let's do this one in whatever mode my calculator's in. Right now, my calculator is in degrees, so let's do this in degrees. So I need to figure out what angles have a sine of 0.65. There should be two of them, one in the first quadrant, one in the second quadrant. If I take the inverse sine of 0.65, I get that theta is equal to 40.54 degrees. That's my quadrant 1 answer. What my calculator isn't telling me is that there's another solution in quadrant 2. I have to find that for myself. For my angle to have a sine of 0.65, it has to have the same reference angle. So if I have a reference angle of 40.54 degrees, then I need to figure out what my actual angle is from here to here. To find that, I can do 180 degrees minus 40.54 degrees. And 180 minus 40.54 is 139.46 degrees. So we also get that theta can be 139.46 degrees. These are my two solutions between 0 and 360 degrees, but it wants all of the solutions. So I need to add 360 degrees k to both of them, where k is any integer. So they're saying go to that angle and go around the circle however many times you want, either direction, as long as you end there, then you have the right sine value. Next up, we're going to find all of the solutions to cosine of x equals -4/5 on the interval 0 to 2 pi. So this time we're in radians. Make sure I switch my calculator over to radian. Okay. So if I type in the inverse cosine of -4/5, this will give me one of my answers. The inverse cosine of -4/5. I am getting my angle, new marker. Our angle was x, so we get x is equal to 2.4, nope, it's going to be 49, but it rounds up to 50. So x is equal to 2.50. Well, our cosine value was negative. That happens in quadrants 2 and 3. So we need to figure out what quadrant this is in, and if we can find the other angle in the other quadrant. So if we're thinking in terms of radians, this is 0, pi over 2, pi, 3 pi over 2. 2.5 is less than 3.14, so this is putting us in quadrant 2. So we know that that angle is 2.5 radians. The problem is I need to find my angle in quadrant 3 as well. So how would I go about finding that? We know we have to have the same reference angle as before, but I don't know my reference angle yet, because my reference angle is this guy. So let's start by finding that. My reference angle, I'll call it theta sub r, because that's what I'm used to calling my reference angles. To find that little bit, I'm going to have to do the full pi minus the 2.5. And pi minus 2.5 is equal to 0.64. So that's my reference angle. That means this little bit is also 0.64. But I want the full angle, which would be from the beginning all the way around to there. To find that angle, I'm going to have to do pi plus my reference angle. And pi plus 0.64 is 3.78. So it looks like my two solutions on the interval 0 to 2 pi are x equals 2.5, which our calculator told us. And then the second one was x equals 3.78, which we just found. Now we're going to find multiple solutions. We're going to solve the cosine of x equals 0.71 for the smallest three positive solutions. I'm going to pull out a separate sheet of paper just so I know I have room. The cosine of x is equal to 0.71. Well, right now I'm in radians, so I'm going to stick with radians. So if I do the inverse cosine of 0.71, I get that x can be equal to 0.78. I need to figure out where this angle lies. Well, it's positive, and cosine is positive in angle in quadrants 1 and 4. That's pretty small. That's going to be in quadrant 1. So we know this angle is 0.78. We need the other angle that works. So it's going to be in quadrant 4 because that's where cosine's positive. And it's going to have the same reference angle, the 0.78. So to find the actual angle, we need to go all the way around from the beginning to there. We're going to have to take 2 pi, the full distance around, and subtract the 0.78 reference angle. And 2 pi minus 0.78 is equal to 5.50. So we have our two solutions between 0 and 2 pi, but it wants the smallest three positive solutions. So if we write out all the solutions, we have x could be equal to 0.78 plus 2 pi k, and we have x is equal to 5.50 plus 2 pi k. We already have our smallest two positive solutions, the 0.78 and the 5.50, because we get our first quadrant and our fourth quadrant. Our next solution is going to be in the first quadrant again, because remember, we're only going positive. So we did our first quadrant, our fourth quadrant, first quadrant is going to be the next one again. So if I let k equal 1, meaning I'm going around the circle one time in the positive direction, then we get 0.78 plus 2 pi times 1, which is just 2 pi. And our next solution is 7.06. So those are our solutions. Next up, we are solving, oops, dropping a marker. 3 times the cosine of 4x is equal to 2 for the smallest 3 positive solutions. This one's going to work really similar to the last one, but this 4 is going to try to trip us up. So first of all, I'm going to want to take the inverse cosine, but I can't until I get my cosine alone. So I'm going to divide both sides by 3. That means the cosine of 4x is equal to 2/3. Now I can take the inverse cosine of both sides. I take the inverse cosine of 2/3. I'm getting 0.84106 stuff. Notice when I take the inverse cosine of this side, I still have 4x. So we get 4x is equal to this 0. I'm going to take it out to 4 decimal places, 8411. That's one solution. I need the one in the other quadrant. So notice that my cosine is positive. I need the answer in the fourth quadrant because that's the other place where cosine's positive. So we know that our little reference angle, because we're in quadrant 1, is 0.8411. To get my fourth quadrant answer, I'm going to have to take 2 pi minus that 0.8411. 2 pi minus 0.8411 is equal to 5.4421. This is still 4x is equal to, so I'm going to carry that along too. 4x could also be equal to 5.4421. These are our general, or our two solutions between 0 and 2 pi. If we want to look at all of the solutions, I need to add 2 pi k on the end. Now I need to solve for x. That means divide by 4. That means divide by 4. Means divide by 4. Means divide by 4. 4x over 4 leaves with just x equals, I need to take my 0.8411 divided by 4. Gives us 0.2103. And then 2 pi k over 4 reduces to pi over 2k. Going to do the same thing over here. We get x is equal to 5.4421 divided by 4 is 1.3605 plus pi over 2k. So we have our general solutions. Every solution will be in one of these forms. We know that our first solution is this guy, 0.2103. This is another solution, 1.3605. What happens if we let k equal 1 in this case? 0.2103 plus pi over 2 is equal to 1.78. 1.7811. Those are our 3 smallest solutions. You might be asking yourself, well, what if this was in degrees? And I'll do the next one in degrees so that we can see that one. This is how you would work it in radians. So finally we want to solve, oh man, we can't do this one in degrees. That it just screams radians because of the pi. Okay, I'll go back. If you wanted to do this one in degrees, you would have your calculator in degree mode when you took the inverse cosine of both sides, and you'd get 4x equals whatever degrees it gave you, plus 360 degrees k. So when you divide by 4, you get x equals whatever plus 90 degrees k. You'd still have to find your second solution in the fourth quadrant, but it would work out the same way. All right, I see the pi. I'm thinking radians. Let's make sure my calculator's still in radian mode. It is. Okay. We are solving 3 times the sine of pi over 4x is equal to 2 for the smallest 3 positive solutions. First things first, I need to get that sine by itself, so I'm going to divide both sides by 3. And we get the sine of pi over 4x is equal to 2/3. All right, let's get that sine out of there by taking the inverse sine of both sides. The inverse sine of 2/3 equal to this guy. Remember, if we take the inverse sine of both sides, I still have this guy. So we have pi over 4x is equal to 0.7297. But that's only one solution. There's another place where sine is positive. Go over here. Focus. Actually focus. Oh, you had it. Come on. This is 0. This is pi over 2. This is pi and 3 pi over 2. 0.7297 falls in quadrant 1 because it's less than pi over 2. Because pi over 2 is about 1.57. We have our first quadrant angle. Sine is also positive in the second quadrant. So I need my second quadrant angle that still has this as a reference angle. So because that was our first quadrant angle, that is my reference angle, 0.7297. So to find my full angle, my quadrant 2 angle, I'm going to have to do pi minus my reference angle, 0.7297. And that gives me a second quadrant angle of 2.4119. So we had our first solution, pi over 4x is equal to 0.7297. And then we get our second quadrant answer, still pi over 4x is equal to, and then we got 2.4119. Those are our two solutions between 0 and 2 pi. But we need all of the solutions because we're trying to find the 3 smallest ones. So I need to add 2 pi k. I haven't solved for x yet, so we have to be careful. I'm going to divide both sides by pi over 4. And let's do it in a different color. So here we get x is equal to, if I take 0.7297 divided by pi over 4, make sure when you divide by pi over 4 it's in parentheses. We get 0.9291, and 2 pi divided by pi over 4 is 8. So we get plus 8k. I'm going to do the same over here. I'm going to divide both sides by pi over 4. That'll give us x is equal to 2.4119 divided by pi over 4. gives us 3.0709 plus, we said that was 8. Okay. So we have our two smallest solutions. They're just sitting there. So we have 0.9291 and 3.0709. If I add 8 to this one, I get 8.9291. If I were to add 8 to this one, I'd get 11 point stuff, which means it's not smaller than this. And these are my smallest three solutions.